Okay, question 20 gives us two functions, f of x and g of x. And we're first asked to find the inverse of g of x. And to do that, we need to set g of x is equal to y, make x the subject, and then transform that back to g to the minus 1x. And then we've got to solve what g fx equaling to 3 is. Okay, let's get part A out of the way first. Okay, let y equal g of x. So therefore I can say, multiplying across, therefore 5y is equal to root x plus 2. We want to make x the subject, so first of all make root x the subject. So therefore the square root of x is equal to, this remains the same, 5y, and it's joined by 2, but now that's negative 2. So therefore, squaring the left-hand side, just get x, and squaring the right-hand side, I can't do anything about them individually, so this is 5y minus 2 squared. So swapping x for y and y to x, this becomes y is equal to 5x minus 2 squared, and that is equal to g to the minus 1 of x. And there is your first answer. Okay, now for part B. And we're told that g(f)(x) is 3. So what we've got to do is we've got to take the f function as it is, which is 3x plus 4, and insert it in here. So that x there becomes 3x plus 4. So therefore I can say that g(f)(x) is equal to the square root of fx, which is 3x plus 4, plus 2, and that's divided by 5. And we know that is equal to 3. Change that equal sign. All right, cross multiply and then expand. So I get that the square root of 3x plus 4 plus 2 is equal to 15. So therefore the square root of 3x plus 4 is equal to 13. To get rid of the square root, I'm going to have to square both sides, and I get that 3x plus 4 is equal to 169. So moving up here, therefore 3x is equal to 165, and therefore x is equal to 55. And there is the answer.